Intake and output. Intake can also be called input. So basically what it is we're determining how much a patient's taken in milliliters versus how much they're taking out in milliliters. So whenever you're monitoring a patient's intake and outtake, you want to make sure that they're not putting out more than they're taking in, because that can be very dangerous. Even if they're putting in the same amount they're taking out of their bodies, it's still dangerous. So you want to make sure that they're not dehydrating, or many different science things that's going on there. I'm not going to dig into that, but I do want to talk to you about the math part and how to calculate this. So the first part we're looking at, it says we have a patient who consumes 2 ounces of ice pop. In this case here, this ice pop is considered as a popsicle. So a little helpful hint, a popsicle, for every 1 popsicle, it is 3 ounces. Of course, they have already measured it out because it's in a container that's already been done that way. So we're not going to need the 3 ounces for this part. So guys, watch for this. If I literally say 2 popsicles, well, then we know that it's going to be 3 ounces. Okay. However, in this case here, that popsicle is already in a container, been weighed at 2 ounces. Okay. So I just wanted to give you that little heads up now. All right. So we have 2 ounces of an ice pop, and we have 30 milliliters of ice chips. Okay. So let's talk about ice chips. Whenever we have ice chips in a container, once it gets to room temperature, it melts down. And so you can have a cup that's full of ice, right? And then after it sits in the room for a little while, it goes down half the volume. So that means whatever we get, we're going to divide it in half. We're going to divide it by half, by 2. Or you can say I'm multiplying it by 0.5. We're taking half of whatever we got here. Okay, so we're going to read off the rest. It says they have an infusion of 125 milliliters per hour. So we got a parenteral intake going on as well. And then the catheter emptied 800 milliliters by 6 or at 6 p.m. Then it says 80 milliliters were emptied in a drain. So it could be a wound drainage. I didn't get into the science part of it. We just know that there's a drainage that the patient is suffering from. And it said it was at 6 p.m. So we got all this information. We need to know what is the underlying question. And I like to read it first sometimes, because it helps me understand what part of this application problem I'm really needing. Because sometimes you're given way too much information that's not relevant to the case. I'm not saying it's not important. It does factor, but sometimes what you need to deal with at the very minute doesn't include everything. So you got to be able to decipher it. In this case, this scenario is pretty straightforward because our shift is 6 a.m. to 6 p.m. And if you notice, they emptied at 6 p.m. The drainage is at 6 p.m. And then the rest of this is saying that it happened during the shift. So we know that all this is going to be factors. Okay, so let's do it in parts. It says we have 2 ounce ice pop. We have 30 milliliters of ice chips, right? So before I do the rest, I'm going to take care of this. Well, what is the relationship between ounce and milliliter? Well, I know for every 1 ounce, that's 30 milliliters. All right, so that's saying all I need to do is take this 2 and multiply it by 30 milliliters. And it gives me 60 milliliters. Okay, how do I know that? Because that means I would have divided by 1 ounce, times it by 30 milliliters. Look, that's all we had to do. All right. So now let's do the next one. Well, the next one said it's ice chips. And again, we're going to take half. So I'm going to divide it by 2. What is half of 30? That's 15 milliliters. All right, so good so far. Now let's talk about the IV. infusion. It says we have a flow rate of 125 milliliters per hour during the shift. Well, 6 a.m. to 6 p.m. is a 12-hour shift, right? So if I multiply this by 12 hours, then I'm able to tell you how many milliliters they consumed during them 12 hours through the IV. So I need to say 125 times 12 is 1,500 milliliters. All right. So now let's clean up our intake. Of course, now on the intake chart that the medical field actually has in like oral, you're going to have an IV piggyback, and then you'll have the output, and you may have more intakes here too. So it would be broke down, and you would do it by the what time each of these events happened, and then you'll have the grand total at the bottom. However, right here, I'm just going to ask you, what is the total intake for this shift? So to know that, I know that I'm taking 60 plus 15 plus the 1,500. So we're going to add it up, and we get 1,575. It's the milliliters, don't forget the unit, is my intake for the patient on the shift. Now let's look at the outtake. The output here states that we have 800 milliliters from the catheter that was emptied, and then we have 80 milliliters of drainage. So we're going to add these two up, and again, these would be two separate columns on the output chart, because they're going to be able to decipher, because you want to make sure what is coming, if it's just all urine, or if they're sick and they're vomiting, or if they have a wound drainage. These state records you want to keep track of, because those are serious things to watch for. So this gives me 880 milliliters of output that's coming out of this patient. I'm not in the medical field, but that is a close race, is to make sure the factors are not dangerous for this patient. So that is the input and output.